frequency of radiations. Now the question that triggers is, why only moving particles? Light is both a wave and electron and a proton move with the same speed, which has got higher de Broglie wavelength. De Broglie wavelength is inversely proportional to potential and charge. Hello students, let us continue our discussion on dual nature. My today's discussion is a very significant discussion which is related to the topic of matter waves and hence establishing the wave nature of particles. To begin with, let us recall what we initially understood in this chapter, where we told light, which was basically treated to be a wave, was confirmed to be a particle, and we told light has dual nature in it. We understood if we have to explain the phenomenon of interference, diffraction, polarization, light has to be treated as a wave. And if we have to understand particle effects like photoelectric effect, Compton effect, Raman effect, light has to be treated as a particle. So which essentially concluded that light is both a wave as well as a particle. This question made people to think, then why not moving particles can behave as waves? When light, which was a wave, behaves as a particle, why not particles behave as waves? And the answer was yes, which was established by the French scientist Louis de Broglie. So de Broglie brings in the concept of matter waves, which clearly established that particles like electrons can also behave as waves. So now the first concept we try to understand is matter wave. It's simple to understand. It is the wave nature associated with moving particles. If you look at the board, I have underlined the word moving. Wave nature associated with moving particles like electrons. So very astonishingly, it is the wave nature which is linked or associated with moving particles or particles in motion. Now the question that triggers is, why only moving particles? Why particles at rest do not exhibit matter wave nature? Understand, dear students, when you call something to be as a wave, it is a carrier of energy. First PUC lo odidira. Wave is a carrier of energy, and also it is a carrier of momentum. The key word that is associated with a wave is that it is a carrier of momentum. And momentum is written as the product of mass and velocity. If the particle is at rest, can it have velocity? No. If there is no velocity, there is no momentum. If there is no momentum, then it is not a wave. Therefore, we say the wave nature associated, linked with moving material particles, only with those particles which are in motion. It is called matter waves, or it is also called de Broglie waves. So understand, students, the first concept that we study today is something called a matter wave, where we say it is wave nature, wave type behavior associated with moving material particles, only those particles which are in motion, like electrons, also called de Broglie waves. Now, we shall derive an expression for de Broglie wavelength. Now, what is this de Broglie wavelength? Wavelength annodna odidira. Some distance between two particles in a wave which are in phase, which exhibit same state of vibrations. Then what is de Broglie wavelength? It is the wavelength associated with matter waves. Wavelength associated with moving material particles. That is what is called de Broglie wavelength. So it is the wavelength which is associated with moving material particles, or so-called matter waves. Now, as we have studied in the previous session, energy of the photon is given by E is equal to h nu. Packets of energy, odadwala, characteristics of photon, properties of photon, where we told the energy of the photon is given by E equals h nu. What did we call h? Planck's constant. E nu, frequency of radiations. Now, from Einstein's mass energy equation, Einstein showed mass and energy are interconvertible. From Einstein's mass energy equation, E equals mc square. Very famous relation. All of you should be exposed to that. So energy of the photon is given by E equals h nu. From Einstein's mass energy equation, E equals mc square. Left hand side of both the equations we have energy. So I re-equate the right hand side. So we get h nu equals mc square. Now, as I told in the previous class, wave velocity and wavelength are related by the expression V equals F lambda. For photons, which are nothing but radiations, speed is c, frequency is nu, wavelength is lambda. So nu is equal to c by lambda. Artha ಮಾಡ್ಕೊಳ್ಳಿ. For any radiation, what we call as a photon, C equals nu times lambda, where C is the speed, nu is the frequency, lambda is the wavelength, or nu equals C divided by lambda. So substituting here, see, substituting for nu, what did we get instead of nu? It is C divided by lambda equals mc square. A C and C gets cancelled. So h by lambda is mc, or lambda equals h divided by mc. And this lambda is what we call as de Broglie wavelength. Now, concentrate here. M into C, mass into speed, is giving me what? Momentum. Since it is C, it is nothing but momentum of the photon. So we write lambda equals h by p, where p is nothing but m into c, which is the momentum of the photon. If it is a material particle, velocity is v, so momentum is m into v. So de Broglie wavelength becomes h divided by mv. So please do know this. De Broglie wavelength is always h, Planck's constant, divided by momentum. So very clearly here, lambda is inversely proportional to mass, and lambda is inversely proportional to velocity. Usually 1 mark question ಕೇಳ್ತಾರೆ ಈ consequence ಮೇಲೆ. An electron and a proton move with the same speed, which has got higher de Broglie wavelength. The particle which has less mass will have more de Broglie wavelength. The particle which moves with less speed will have more de Broglie wavelength. Now, we will try to calculate de Broglie wavelength in terms of the kinetic energy of a particle. Students, we know kinetic energy is half mv square. Kinetic energy of any particle is half mv square. Very much established work, power, energy chapter. Take 2 to the numerator on the left hand side. 2e is mv square. Now my sense is somewhere de Broglie wavelength has to be associated with momentum. Momentum which is of the form m into v. So what do? I multiply both sides by m. 2me is m square b square. 2me, when again you multiply m square v square, or taking the root of this mv. mv is nothing but p. So therefore, kinetic energy in terms, we can write lambda is h by p. But what is p now? Root of 2me. So lambda is h divided by root of 2me. This is the expression for de Broglie wavelength in terms of kinetic energy of the particle. Quickly we will summarize again. Kinetic energy is half mv square. Correct? Fine. I know when I define de Broglie wavelength, it is somewhere associated with momentum. Momentum is of the form m into v. So 2e is mv square. Somewhere on rearranging, I mv anta tako bande. Now multiply both sides by m. On both sides of that equation, I multiply by m. 2me equals m square v square. I want to eliminate the square so that I get off the form mv, momentum. Take roots. Root of 2me equals mv, or root of 2me. This mv is momentum. So we know de Broglie wavelength is h divided by p. Instead of p, root of 2me, and this gives me the wavelength in terms of kinetic energy. Now de Broglie wavelength in terms of potential, lambda is h divided by root 2m vq, where v is the potential applied, q is the charge. So this is the expression for de Broglie wavelength in terms of potential. Lambda equals h divided by root 2mvq, where m mass of the charged particle, p applied potential, q charge of the particle. Again, if you see, de Broglie wavelength is inversely proportional to potential and charge. So students, in my today's session, we discussed a concept called matter waves, where we told the wave nature. Wave type behavior associated with moving particles, particles essentially in motion, is called matter waves or de Broglie waves. We studied something called de Broglie wavelength and wrote the expression in terms of kinetic energy and potential applied. And we told de Broglie wavelength is inversely proportional to potential, mass, velocity and charge. In my next class, I come up with a very beautiful experiment which proves the wave nature of electrons. Until then, have a nice time. Thank you.